Sometimes you can't apply the table of integrals to your integral. So it means make a connection between the table and the integral is not very obvious. Let's say x times x squared plus 5 to the power of 9 dx. I want to take this integral. There is no formula in the table that helps me to do this. This is why we have substitution method. Before I start substitution method, I'm going to remind you that when y equals f of x, then dy over dx is f prime, obviously. And then dy can be written as f prime x dx. So, for example, if y equals x squared, dy equals, according to this formula, f prime, which is 2x times dx. If, for example, v equals r cubed, dv equals the derivative, which is 3r squared dr. If u equals sine x, du equals the derivative, which is cos x dx. Okay, so we needed to know this formula of differentials, and now I'm going to get back to my integral to see how to do it. So in this method is called substitution. So we substitute x squared plus 5 by u. Then according to this formula that we just learned here, and I'm going to make it yellow here, highlight this. According to this formula, du can be written as 2x dx, or du over 2 equals x dx. Now let's rewrite our integral in terms of u alone, no more x. So this green part can be written as u to the power of 9. And these two together, the blue ones, x dx together, according to this, equals du over 2. Taking 1/2 out of the integral, so we will have this. And this is what you know from the table. So very simple, you use the exponent law, which becomes u10 over 10 plus c, or 1 over 20 u to the power of 10 plus c. We need to get back to x because I brought up u. There wasn't any u here, right? I made it up. So 1 over 20, u is replaced with x squared plus 5 to the power of 10 plus c. Let's have another example. So we are given integral of tangent x dx. I'm going to write tangent as sine x over cos x dx. Now I'm going to set u equals cos x, the denominator. Therefore, du equals negative sine x dx, or negative du equals sine x dx. So this one is exactly u. As you see here, the correspondence between yellow ones, and these two together, sine x dx together equals negative du. Then I'm going to rewrite my integral, and in the new integral there should be no x at all. So sine x dx on top can be replaced with negative du, and the denominator is u, du over u, and you know according to the table of integrals that integral of 1 over u is ln u plus c, which is negative ln absolute value of cos plus c. We are done, but sometimes you may see in some textbooks they use this negative 1 over here according to the properties of log. Then it becomes ln 1 over cos x plus c, and 1 over cos is secant, so it's going to be ln plus c. So let's have the last example. So x e to the power of 1 minus x squared dx. I'm pretty sure that everyone has a question that how do I know which part is u? There is no way to determine which one has to be u. It's completely is depending on your experience. The more you do, the more you experience integral, the better you can determine which part is better to be set as u. However, there is one key point. Whatever you choose as u, its derivative should be around. For example, here, if I set this one, the yellow part, as u, its derivative is negative 2x. And since x is here, and negative 2x is just a multiple of x, that would be a good choice. Let's see how it goes. So let's set u equals 1 minus x squared. Therefore, du equals negative 2x dx. And then negative du over 2 equals x dx. Now I'm going to rewrite my integral in terms of u alone. So e to the power of u is obvious because 1 minus x squared is u. And as you see, x dx together, x dx together can be replaced with negative du over 2. Therefore, you can write it negative 1/2 eu du, and according to the table of integrals, it's negative 1/2 eu plus c. And at the very end step, you'll replace u with 1 minus x squared. And we are done with this method. Of course, some of questions are more challenging. That's another story for another day. But in this lesson, I just wanted to clarify the concept of substitution and go over some easy questions. I will dedicate another lesson to more challenging questions though later.